Hello everyone, welcome back to the TronicsMate electronics channel. So today I'm going to discuss about ESP32 C6 board where I will explain you schematic and PCB and finally share you the Gerber files with the BOM. So let's move on to the designing part. The design is already done and verified. Just I am going to explain the design which will help you throughout your projects based on ESP32 C6. So I will move to the designing. In the design is done in KiCad. So in KiCad I have the schematic and I have the board which is already completed, and this is how it will looks like as a product. So I will cover each and everything and explain you, so stay with me until I finish this video. This video will take about 30 minutes because I wanted to explain you in detail each of every part of this design. Well, let's move to the schematic first. In the schematic consists like mainly the four parts. I have divided them into the four parts. One is the programming side and power supply side, and mainly the ESP32 C6. We have to rename this as C6. It look much better then. And the GPIO headers, which are the output pins for the users. So let's move to the ESPC6 part first. So basically, this ESP32 C6 module very similar to the ESP32 room, the old module, and but have better capabilities. And basically, this is the again I have to mention that this is a board with minimum required components. So let's say with this board, I have not used like extra crystals which are for like sleeping or kind of things, and just I have added only the required things. So first of all, the power supply side, the power we are using is 3.3 volt. So this module supports something like 3 volt to like 3.8 or something like so normally the 3.3 volt is the voltage most of the people are using with the SP32. So I use the 3.3 volt, and these two are the capacitors for noise filtering and voltage stabilization. And here we have the reset circuit. So the reset circuit will pull this enable pin low, so the module will reset like a reboot. So this reset button is useful when you are downloading programming, or if module is stuck on the middle, like some kind of due to a firmware issue or something like that. So one thing important here, we have to add the RC circuit, like a relay circuit, to this enable pin, because whenever you apply the 3.3 volt, that 3.3 volt comes here, and it comes here first, and 3.3 volt comes here, and the enable pin here is still low. So that enable will happen after some delay. Once this power is applied, it is recommended by ESP32 for better for the correct boot up. Otherwise, if we do not use this RC combination, there might be you might be see some problems in your design. So the RC like the RC circuit, the ESP has suggested is one circuit is like you can use 10K with 1 microfarad, or keeping the same RC constant. I used 100K with zero point 0.1 microfarad. This is tested and proved to be working. So this is the reset button, which can be used triggered by the user in two purposes. One is you can use it for the reset, and second one, whenever you are downloading the program, you can use this one to reboot the module. And pretty much like the older modules, we have RxD and TXD, which are used for, which can be used to download the program as well as communication. And not like the other modules, we have direct USB interface in this ESP32 module, ESP32 C6 module. So which is an advantage. So we do not need USB to TTL adapter. Like in previous board, we used, if you watch my previous design with ESP32 Room, which is all the module, and we had to use the USB to TTL bridge like CH340. But in this case, we got native USB port in the module. So we have USB 2.0, so we can directly connect the USB port to the module, which is a good advantage. We can reduce the cost of the design, lot of stuff. So we can get rid of the USB to TTL bridge that takes some cost and also space in the PCB design. So it is good thing to remember that you can use either this USB port or this RxD still you can use that one to download the program. So uh, and other than that, all the GPIOs are there, and from this GPIOs, some GPIOs are the state of some GPIOs is important. So which are the strap pins? So I will explain the strap pins. So in this module, the strap pins are GPIO 8 and GPIO 9. Hopefully, you remember if I watched my previous video for ESP32 row, the GPIO 0 is the boot pin. But in this module, you have to remember that GPIO 9 is the boot mode select pin. And in all the ESP32 row, GPIO 2, you have to keep it high, otherwise there might be a program downloading issue kind of thing. So in similar situation here, the GPI or 8 should held high if you want to download the boot. Like you have to download the program, otherwise you can't download. So you have to keep remember that when you are using when you are designing a custom board, if you are connecting some things like some devices, some sensors to GPIO 8, if it is held in the GPIO 8 law, if it is forcing the GPIO 0 law when we are trying to download the boot, then it is not good. You will not be able to download the boot. So that is one important thing to remember. So GPIO 1 should be held high in order to do for a normal boot. The SPI boot is for the normal boot. The download boot is for the download mode, the firmware download mode. So in order to maintain the this number one, I mean the GPIO high level, I have added 100K resistor, like pull-up resistor to GPIO 8. And also they are saying that they already have a pull-up resistor inside the module for the GPIO 9, but for the GPIO 8 they kept it 14. So it is very important you are adding this pull-up resistor. And so even though they have internal pull-up, I still use the external pull-up also, which is 100K. We can omit this, but maybe I didn't I couldn't check the how strong that internal pull-up is. So anyway, I added this 100K. So it is better if we added like debouncing capacitors across the buttons. But as I said, this is minimal design, but we can add debouncing capacitors, which will be better in terms of designing. Okay, now let's move to the power supply side. So this is anyway, before finishing this, I will say these are the minimum components you need with ESP32 C6. So now move to the ESP32 power supply. The power supply, uh, the ESP32 datasheet says we have to use at least 500 milliampere power supply. So I am using LDO, which is not very power efficient, but in this circuit I wanted to keep it very simple. So this is linear regulator which can output up to 800 milliampere from Texas Instrument. So this can be powered either from USB or from Vin. With this Vin is connected to the GPIO, like output pins. So user can supply power from outside or like through the USB. So we have two diodes connected. This diode will select the power supply, like whatever the power supply has the higher voltage will be selected by two diode combination. So hope you are clear about this diode thing. And the power supply side, this is the basic circuit, like a basic required circuit, like input capacitor with the output capacitor to stabilize the output voltage and also the input side. Then I am moving into the programming. So in the ESP32 programming side, I have used the USB Type C connector, and for the Type C connector, we must use 5.1 kilo ohm resistors to make it a slave device. So once this is a must thing in circuit, like we have to add this 5.1 kilo ohm resistor. So you have to keep in mind if you are using a Type C connector. If you are using micro USB or something like that, you will not see the CC pin, so you do not have to worry about that. But Type C is the like nowadays trend, so people want Type C connectors. And we have data plus, data minus and data plus, which is going through this IC, which is the ESD protection IC for the USB. I added that for the because the module need some ESD protection from the USB, which can occur, which can damage the module. So this IC will take care of that. And the USB data line comes out. These data lines are connecting to the USB data minus and USB data plus, which are the IO12 and IO13 pins. So these are in their data sheet. So if you want more details, we can refer. But okay, now how we can download the program, like how we can program the ESP32 module. So what you have to do is you are connecting a USB cable here, but normally module is in the SPI boot, as here the normal mode is the SPI boot. Every time you are turning on the module, is go to the SPI mode, so like normal mode which execute our program. But if you want to download the boot, you have to hold GPIO 0 low, which means we can press this button, the boot button, and restart the module. What user can do is press and hold this button, and same time press and release reset button, and after we release the reset button, we can release the boot button. So in that way we can put the module into the boot mode. Once the boot mode is there, the module we can use a program download like tools such as, for example, Arduino, and uh, try to download the program. It will accept the program and it will erase the memory, and it will get write the new program to the module. So that's how this USB port programming works. So there is a manual operation, as I said. We user have to press the two buttons. If someone wants to use the external programmer, something like so the one advantage is with the this kind of program is like you can use serial print, like in the Arduino you have serial print, serial write kind of things which are useful in debugging the program or something like that. So in that case, I did not add USB to TTL adapter, but it is not hard to add. In my previous video, you have the schematic for the USB to TTL adapter, which is using CH340. If you want to add that to this design, what you have to do is you have to add another USB-C connector and copy the whole circuit from that design, the previous design, and you have to change the in old module we were using IO0 as the boot pin, but here we are using IO9, so we have to replace the IO0 with IO9. That's all. So it's very simple, but in this particular case I did not add that USB to TTL adapter. um, but if you want to add that, if you need any support, you can comment. You can add a comment to the video and I will check and I will help you. Okay. Right now here we have the adapter for the external USB to TTL uh, connector. Like you can use whatever the module in the market, like CP2102 IC or CH340 based USB to TTL adapter. Like if you go to Google and like USB to TTL, there are a bunch of things coming on. Like you can see a lot of adapters are there, and you can use with this design you can find a good adapter with the DTR and RTS signals. So the advantage is I added this auto reset circuit, which do that that manual procedure which we have to do with these buttons automatically. So these two transistors can do that. Like what they do is they first, once we hit the download program, these DTR and RTS signals are triggered. According to those signals, first it held the IO9 and then it reset the module. So that module goes into the boot mode. Then using this RxD and TXD pins, we can download the module. We can download the program to the module, which is pretty much easy. So you don't have to press and hold any button. Okay, that's all regarding the schematic. Now let's move to the like finally GPIO header. We have like V bus, V in, and 3.3 volt reset pin also there as output, and the output pins. Let's move to the PCB design. Now the PCB design I have already completed, because I did not if I do that while doing the video it will take long. So what I did is I completed the design and I wanted to explain, and I will supply the Gerber files and BOM file so you can check the design. Anyway, okay, now let's move to the, this is like nothing much fancy about this design. I mean, uh, you have to take care of few things. First thing is the antenna. So the when you are placing the ESP32, you should place it in a PCB edge, and it is better. You should not place put any copper or any component behind that antenna. So here is the antenna of the module. So if you look at the 3D view, you will see here is the antenna, and I have made a cutout. You can see this cutout. Let make sure that there is nothing behind the antenna, so that signal reception and transmission, like it will be much better. So that's why I have used the cutout. If you can't use the cutout, at least you must, not at least, you must make sure that there is no copper or no components inside this area. So that is one very important thing when you are designing something with the ESP32 module with the PCB antenna. If you are using an external antenna, that is not a problem. Then you don't have to think about this. Then the capacitors, the voltage stabilization capacitor and noise filtering capacitor, these must be placed very close to the voltage input pin, which is this pin. And the reset circuit also I have placed close to the uh, reset pin. Okay, then let's move to the that then the GPIOs are directly connected using these traces. So this I have arranged in a way that we can easily route the PCB, and this side also same, the GPIOs are routed. So now next move to the power supply. The power supply, we have this LDO and two capacitors are placed close to the power supply. And so the ground connection of the capacitors must be strong. So in this case it is better to add more wires so that it conduct better with the PCB ground plane. So because when we the ground loop also should be very close. In this case the ground loop of this one, it is okay, but yeah, so the ground loop from the ground pin of the power converter, like the LDO linear regulator, to the capacitor should be close, should be where good, I mean it should not be too long. Okay, then let me turn off this the sounds for you so you can have a better view. Now let's move to the USB side. So in the USB side, the USB data line. So this is one thing I have to mention. So in this design, to save the cost, I did not go with the 4-layer design. I hope you have seen in most of the time, even like most of the custom board, like the Arduino board, kind of ESP32 boards, are 2 layers because to save the cost. So um, but for the USB data line, we should maintain 90 ohm impedance for these differential pairs. But when we calculate the differential pair width and the space for the 90 ohm for this 2-layer board, the 2-layer board is 1.6 millimeter, and that is the normal width. We can go with the lower width, but I use the 1.6. The trace width we are getting is high, so I try to keep it close as possible, but not exact. But I have checked with the other designs before, and it is proven to be working with this kind of especially since the distance is low. So the distance is like maybe 30 millimeters, so kind of. So it won't be a big problem, but it is better if we can make this distance much lower. In this case I couldn't because of these two pin headers, but if you are doing a design, if you are going with 2-layer, just make sure that the if you are not using the impedance control like a 4-layer impedance control, so with the 4 layers we can easily draw the small like trace which are matching 9 to ohm. But with 2-layer it is very hard because of the width you are required to draw. That width does not support this kind of tiny module, like tiny connections. So what I suggest you is make this distance very small so that you will not see any USB issues. Okay, that is the regarding the USB. And then move to the uh, program header. So in the program header I have I have for the user experience, like a better user experience, so that user I have marked all the connections in the program header, so user can easily identify the connections and connect the cables and use external programmer to program this board. Okay, That's all regarding the PCB. Let me check whether if I have missed something. So in this PCB, it is much better if I improve the ground loop, like removing this kind of isolated ground. I mean, not much isolated, but this end is connected to nowhere. So normally this kind of end may act like antennas. It is not good. It is not good to have such a ends with RF base circuits. So normally once you finish the design, you should place some wires to improve the connectivity between top ground layer and bottom ground layer. So yeah, and also it is important to place some kind of ground wires in the edge of this uh, near the antenna, so that it will again, as I explained, it will because if there is a unconnected end of a ground, like it may act like antenna, so it may affect the antenna performance. So in order to uh, make sure that the design is good, it is better to add some kind of wires. The more wires you add is much better, but you don't want to add too much wires in your design. Anyway, we can add few more in this design. Okay, now I think it is pretty much done. Just once you are done, you have to check for the RDC. So first of all, check the unconnected items is there or not. Then check for the violations. So I am getting two warnings for a silk screen edge cut. So it is not, it is okay. So it is saying that this silk screen, which is a graphic drawing in the PCB, will be cut by the edge of the PCB. It is fine for me. I'm okay with that. And here this is saying that footprint type does not match. It is expected through hole and actual SMD. And again, it is not a big problem for this particular case, so I'm not going to resolve. But if you want, we can resolve that with the change in the footprint type in the by editing this footprint. So let's move to the 3D view. So I always enjoy watching the 3D view of the PCB once it is designed. So you can see how it is arranged. I could make this board much more smaller, like much more compact, but since I didn't have a uh, specific requirement. This is for just demonstration, so I just designed in such a big size. But we can easily go with the smaller board. Even it may be possible we can go with very small board with the components placed in the board side. Okay, that's all for regarding the design. I think you are pretty much clear about the design, and I hope you got some knowledge regarding the ESP32 C6. So what I have to say finally is, if you have already designed a ESP32 room custom board with all the modules, you will not see any challenge designing a new board with ESP32 C6. So good luck for you with your designing. If you need any, if you have any doubts about this video, if you have any comments, you can put in the comments, so I will answer you. And hope to get back to you with more advanced videos. I'm just slowly starting with this kind of simple videos, but keep in touch with the channel and subscribe, because I will upload more advanced videos like we can go for Raspberry Pi CM4 designs and maybe much more advanced videos in future. And may I will I will bring you more power supply designs. I hope to bring you more power supply designs in future also, and also telecommunication modules based design, which is useful for some of the people who are working with the IoT applications. Okay, thank you so much for watching the video, and if you like the video, just like it and subscribe if you like the channel, and hope to I hope to see you again with the more informative video. Thank you so much.